What is up, guys? Fire here from AwesomeTuts.com. And moving forward with our game, what we need to do now is we need to create the blocks that we are going to position here in the water so that our cat will have something to stand on. And before that, I'm just going to go here and let me just comment this out because I do not want this to execute in edit mode because I don't care. We know that it is working, so I don't want it to, well, give me headaches. And notice what you see when it is not executing in edit mode. But if we run the game, you will see, well, a nice water texture here. Anyways, also, I want to say that if you want to learn professional 3D game development along with the advanced scripting and whatnot, you should definitely go here on AwesomeTuts.com. It's the first course that you will see, this one right here, if you want to get high discounts. I told that already, and I will tell it until the end of this series. Download the free assets, all of these that you see here that I used in the project, along with the complete project. The link is in the description below, or simply go on my website and download the free assets here. That will also work. So now, moving forward, we need to go into the models folder right here. So going into the models, here are the blocks. So simply put the block right here and voila, we are good to go. So this is one of the blocks. Let me just go here, select the block. Here he is. What we need to do is first we need to rename it to simply block. And also for the shader of the block, what I'm gonna do is I'm not gonna select the standard one. Instead, I'm gonna go here under this matte cap and we have this vertex and we are gonna select this texture multiply. So vertex, texture, multiply. Automatically, we see here that this block right here is selected, or this texture block is selected. For the shader, we need to select one more. So for the matte cap RGB, so this one right here, and I'm gonna select MAC. So simply type MAC and we want this one, the 2 or the second one. So MA Korea 2. These are imported with all of the assets that we have imported, so do not worry. Before I actually save this as a prefab, I'm gonna duplicate it and go here into the assets, and here we have, or we did not create it, so right click and create the prefabs folder. And inside of the prefabs folder, we're simply gonna drag this first block, so the one that we have created, not the copy, but the one that we created, and I'm gonna remove it. And now we have the second one, which I'm also gonna name block like this. Should I name it block 1? Well, it's not a problem because we will change the name in the code, so don't worry about that. But for this block, I'm gonna also select the same matte cap vertex texture multiply. So matte cap vertex texture multiply shader. And here, for the first image, we're gonna filter for the stone. So we want the stone image. And for the second one, we want this matte cap Korea or May Korea 10. This is the one that we want. So notice now the stone. So notice how it looks like. This is exactly what we want. And we can name it block 1 because we will definitely change that in our code. And I am gonna put or position the block right here. Before we continue to coding and whatnot, I am gonna right click and create an empty game object, which is going to be the block manager. So let me just position the block manager 0, 0, 0. I'm also going to position this block at 0, 0, 0. Let me just change here the scale. And we need to do one more thing, which I forgot to do, and that is select both of these blocks and add a box collider on them. So not the box collider 2D, but a simple box collider. So this is the one that we need. If I go here, so if I just go a little bit here, this is what we have. So we don't see the collider because of the sea, but if I take the daylight water and position it at -0.2, now we will see it. So take the daylight water and position it exactly at -0.2. So notice now how we see the nice blocky. And we also have the box collider attached on it. So this is what we want, and make sure that you have added that box collider on the prefabs. So when you add them on the prefabs, it will automatically apply here for the prefab game object that's now in the scene. We're also gonna take this the block 1 and position it at -3 for the z-axis. So -3 for the z-axis. This is now where our block is, and from here, so this is where our cat is also going to be. But we're not gonna talk or do anything with the cat at the moment. Instead, we are gonna code the block manager. So take this game object, the empty one that we have created, name it to block manager. Go inside of the scripts folder. We have this lean twin. We will use this later on. This is a plugin, so don't worry about that. And I'm going to create here a folder for the block scripts. Inside of the block scripts folder, I am going to right click and create a new C# script, which I'm going to call block manager, and attach the block manager on the block manager game object. Not on the block itself, but on the block manager game object. And also, I know I said that we are gonna name this one in code, but because of the cat and in the cat code or script, we are gonna test if the cat is standing on a game object with the name block. So here we are simply gonna put it back to block instead of block 1. Still in the prefabs folder, if we go here, he is named block 1, so don't worry about that. But because of the, as I already said, because of the cat, inside of the script we will test if cat is standing on the game object whose name is equal to block, then we will do something. Anyways, I'm gonna double click on the block manager and go inside of that script. Let me quickly tag the script here. So class, hold enter to give a little bit of space, and now go above and declare the variables that we need. So the first one is going to be a serialized field, which is going to be a private integer max blocks. This is going to determine how, or the maximum number of blocks that we are going to create. We will change this number later on. It is set to serialized field, which means that it will be visible here in the inspector panel. So notice now it is visible in the inspector panel. And as I said, later on we will change this, so do not worry. But essentially, if we use an array, we will spawn 10 blocks from this variable because the default value is set to 10. Next, we need a serialized field private game object array, and these are going to be our blocks. So blocks, and we also need a serialized field, which is a private game object, which is going to be the last block, and not black, but block. We also need, and this one is going to be public, so public game object cat landed block. But for this one, since I don't want it to be visible in the inspector panel, we are gonna, well, type hide in inspector panel. So just above it, type hide in inspector, and it will not be visible in the inspector panel, even though it's set to be public. So I'm setting it to be public because we will need to access this variable from another class. And what we need to do now is go inside of our Unity editor, and all of these variables that we set to be serialized field, they are now gonna, well, appear here in the inspector panel. What we need to do is drag, or first set the size of the blocks to 2 and drag the block in block 1. So I'm gonna drag block, and I am gonna drag the block 1 inside of this array because we are gonna spawn the blocks from the array. And for the last block, we are gonna drag this one. So make sure, this is essential, drag this block inside of this field right here. For the max blocks, we are not gonna touch anything. Just drag the prefabs here into the blocks array and set the last block, or drag this game object here. Make sure that you do that because it is essential. We don't need any more variables, and instead we are gonna go directly here and create a function that is gonna create a block. So here I'm gonna say create new block. And what we wanna do in this script, or in this function, well, the first thing is that we are gonna create a vector3 position, which is equal to vector3.0. This is just the initial value of this variable. And next I'm gonna create the while loop that is gonna, well, last until we create the blocks, and we test if we have a block at a certain position or point, then we will stop creating those blocks. So here I'm gonna say while true, and this is an infinite loop, and I talked about loops and while loops, and I said the most important thing regarding beginners is when working with the while loop, make sure that you Well, make sure that you know or put the code that will end this loop. Now you're like, this guy is crazy. He's just set here to be true, which means true will forever be true, and this will run infinitely. But just wait until we code and I will show you what I mean. So the first thing here is that I'm gonna say int random is equal to random.range from 0 up to 100. So random range from 0 up to 100, because we want to test now. We are going to give a chance for or where we are going to spawn the blocks. And when I say where, I mean, are we going to spawn them to the right, to the left, backwards or forward? Well, we're going to determine that with the random variable. So now here I'm going to say if the random is greater or actually less than 50. So there is a 50% chance to spawn a block ahead of the last block. So 50% chance to spawn the next block in front of the previous block. And for that, we're going to say position, which is this one right here. So POS is now equal to new vector 3. And here we're going to say last block dot transform, so dot transform dot local position dot x1 f for the y-axis, and for the z-axis we are going to say last block dot transform dot local position dot z plus 1. This is, so local position z plus 1 is going to position the next block in front of the previous block. So this is the last block, and the next one will be positioned in front of it on the z-axis by 1. And what is this local position? Well, if we go here, we added a block as a child in the block manager, which means now that if we want to directly access the transform, we can use transform.position, but the local position is local to the game object itself. It's not local to its parent. Because when a game object is a child of another game object, then its position is relative to the position of the parent. What do I mean by this? Well, I mean, notice now, if I take the parent, so the block manager is set at 0, 0, 0 for X, Y, and Z. And notice the block manager, or the block here, is set at 0, 0, and negative 3 for the Z. But if I take the block manager, who is the parent, and move him here, if I select the block now, notice again, the position is at 0, 0, and negative 3. Why is that? Well, it's a child of this game object. Its position is not changing because its position is relative to his parent. And if we want to change its position, so if we want to put this block at this position, then we will need to access the local transform. So its own position, relative to itself, to his own position, not relative to the parent's position. This is what this local position code means. So now, if this here is true, and since we are in the while loop, which is true and it will run forever, this code will execute 3 million of times before our computer crashes and you go whining to your parents to buy you a new computer because the dude from the internet crashed your computer. Well, we need to make sure that we end the loop, and we're gonna end it if we test that if we have a block at the position where we spawned it. So here I'm gonna say if physics.raycast, and we are gonna raycast it. So we are gonna raycast it from the position, which is this one right here. And we're gonna cast it at the direction, which is vector 3 down. And the length or the distance of the raycast is gonna be 1.5f. And here we're gonna test also, so going here, we're gonna test and if the physics.raycast, and here I'm gonna say new vector 3, and we are going to use position.x, position.y, and we're going to use position.z plus 1. And here I'm going to say vector 3 down, and comma, also 1.5f. And what am I doing? So let me just go here, and voila, we're good to go. So if this happens, we're simply gonna call break. And I am also gonna omit the curly brackets for the if statement because we only have the break after the if statement if we have something like this. So if we say, for example, if 2 is greater than 3 and we want to execute some code. So if we only have one line of code after this, then we can omit the curly brackets that we add here and here, you know? These curly brackets. So if we only have one code or line of code right here in the if statement, we can omit these. So we can remove them and this will still work. Just put the line of code here that you want to execute. And again, as I said and repeat, it will work. This is what we are doing here. So instead of adding here a curly bracket and adding here a curly bracket, I'm simply gonna remove them because we only have the break statement, which will break out of the while loop. And this right here is for the if statement. So what am I doing here? What is this raycast? This raycast is gonna draw a line or is gonna put a line from this position in this direction, and this is the length of that line. So if I take my highlight tool, and let's say this is the position from which we want to raycast, and the direction is down, so down, and this is the length 1.5, so it means it will be like this. So this is the length. Here I'm gonna say 1.5, and we are good to go. This is the raycast. This line, this raycast, so this line is called a raycast because here, as you can see, physics raycast, okay? This raycast, if it touches, so any game object can touch this. So it is invisible, but it can touch. Just imagine some invisible line, and if you try to pass it, it will touch you, just like a laser. And it will detect if it has touched a game object. So if the physics raycast from this position, meaning from, well, this current position, and we are raycasting downwards, and we are raycasting, the length of the raycast is 1.5. If it touches something, it will return true. And we are also raycasting using the current Z position, so POS position, this one right here, and we're adding 1 to it. That means we are checking if 2 places in front of the game object are empty, or the second place. So essentially, if I take one block, so if I take, this is one block, and I am gonna copy it, and notice the next block is gonna be at -2. So this is right here. And next, what we are testing is if the space next, so the next space, this one right here, is empty. So this is the second raycast. If that next space is also empty, meaning we have an empty space, we can create another one, we will break from the loop. Because we already created, the previous space has a new block. So yeah, we are good to go. We created a new block. This is what we are essentially testing right here. And here I'm gonna say else if the random is less than, and here we are gonna say 70. So there is a 30% chance to create, or a 20% chance actually. So here I'm gonna say 20% chance to create a block to the right. So here we are simply gonna say POS is equal to new vector 3. And well, we are gonna use the last block. So here I'm gonna say last block dot transform dot a local position dot x plus 1. Why x plus 1? Well, as I said, we want to create it to the right, and the right is in the positive, so it's gonna be x plus 1. The y-axis is gonna be 1f, and here for the z, we are gonna say last block dot transform dot a local position dot z, because we are not gonna attach the z position since we have created a block to the right of the previous or the last block. So next, we also need to make sure that we are gonna break out of the loop. So I'm gonna copy all of this line of code, and I'm gonna put it right here. And next here, we're not gonna test if the position z plus 1, but instead here we're gonna say x plus 1. So x plus 1 is gonna be here and not z plus 1. And the same concept, so it's gonna draw a line right to the, or using this position, and it's gonna go downwards, and it will check if we have a game object at that position. But here, as I said, we are using position, the current position, and we're adding 1 to it. So it's gonna check if the next space, so the second space, is empty. If that's true, we already created a new block. Here I'm also gonna say else if random. So if rand is greater than 90, so there is a 10% chance to create a block at the left side. So let me just go and put the while statement or the curly bracket for the while, move it here. And this is 10% chance for the block to be created on the left. So we're going to say POS is equal to new vector 3. And we're going to use last block. So last block dot transform dot a local position dot x minus 1f, comma, we're going to have here 1f for the y, and comma, we're going to have last block dot transform dot local position dot z. And now we can copy the same code, which is going to test the same thing, but on the left side. And I already explained it 2 times. So here we're simply going to say POS dot x minus 1, and we are good to go. We can also do something like this. So if I go here, we can use else, and we can create a block. So if I take this right here, and we can say POS, and here it's not going to be x minus 1, but z minus 1 to create the block backwards. But I'm not going to do that. So you can do it, but I am not going to do it. Instead, we're only going to move forwards with our block. So only move forwards and not move backwards. So now that we have determined where the next block is going to be, make sure that you're out of this while loop. So click on the curly bracket and go here and see if the curly bracket is ending for the while loop, which it is because it's highlighting this one. So now we're going to create an integer. So I'm going to say int num is equal to random.range, and it's going to be from 0 up to 100. And if that is greater than 0, and we are going to say question mark, and I'm going to say here 0 and colon 1. What is this right here? Now I forgot how this operation is called. Don't judge me. I know there will be people from you who will be like, oh, technically this is called like that and I need to correct you. I don't care. Just look it up on the internet. But anyways, what is this doing here? What this is testing if the number that we get here, so if the random range number from 0 up to 100, if that number is greater than 0, question mark. That means we are testing if that is true. If it's true, this is the value we want to assign to the integer. If it's not true, this is the value. Essentially, this is what we are doing. So if random.range from 0 up to 100 is greater than 0, then num will be equal to 0, else num will be equal to 1. This code here is doing this right here. So we're testing if the number we got from here is greater than 0. So if that number is greater than 0, if that's true, and we are testing that with a question mark. So we are saying with the question mark, is this here true? Is the number that we get here from the random range 0 and 100 greater than 0? If it's true, assign 0 to the num variable. If it's not true, else assign 1 to the num variable. So this is what we are doing here. And I am going to remove this line of code. And why did I do this? Well, now we are going to say game object, temporary game object, is now equal to instantiate using the blocks. And we're going to pass here the num. And we're going to say as game object. And why did I do this? Well, there is only 1% chance that we are going to create a block like this. So a block exactly like this. Only 1% of the chance. In most cases, we're going to create a block which is like, where is the block? Which is like this. What did I do? Oh, yeah. Stupid me. What we need to do is go into the materials and create a new material, which is going to be block material. And I need to go and attach it. let me just go back here. So it's a block material, prefabs, and I need to attach it on this block. So materials, and attach it on this block right here. We need to go here into the shaders and we need to choose madcap, vertex, texture, what it was, multiply, I think. Was it texture multiply? Yes, I think it is. Block, here it's texture multiply. And here I am gonna filter for the block. So this is the one that we want, and I want this Macria 2. So yeah, now we are good to go. I'm gonna hit apply. So the changes apply to the prefab, and now we are good to go. So this is the block right here. So block and block. And again, go into the block manager, attach the first block, this one right here, and attach the second block here. As I said, there is only 1% of the chance that we're gonna spawn a block like this one, and 99% of the chance that we're gonna spawn a block like this one. Because the stone block, as I said, will be spawned only by 1% of the chance, and this is why we are doing this right here. And again, moving back here, what I did just now is I created a block material, set its shader to madcap, vertex, texture multiply, selected here block 01 as a texture, selected here Macria 2, and attach that on this block material. So prefabs onto this block material, because we want to differentiate the two. We want one stone block and another one is like a grass block. So now that we have a game object, so we created a game object from that array, we are gonna set his position. So we're gonna say temp dot transform dot a local position is equal to new vector 3. We're gonna say here POSX 0 for the Y, POSZ. So we're simply using our position. So this one right here that we created here, or determined where it is gonna be created. So X and Z are gonna stay and Y is gonna be, well, 0. And we can do it right here. So you can also do it here, POS. Here you can set it at 0, but hey, I did it like this, okay? And we're also gonna say temp.transform.parent is equal to the transform in order to set a child to the parent. So as we did here for this block, but if we wanna do it from the code, we will need to say the transform of the child and his parent is equal to the transform, or this is the parent. So it's equal to the transform of the parent. So you use the transform to position or to set a child as a child, or to set a game object as a child of another game object. So you say the transform of that game object and the parent of the transform is equal to which transform, or the transform of the game object for which you want it to be the parent. We also need to say here temp dot name is equal to block, and this is what I was talking about. So we are gonna set the name of the game object to block, because then in the cat script we are gonna test if the cat has collided with the game object that has a name block. That means the cat is standing on the block. And the last block is now equal to the temp, so the temporary. So last block, the one that we are using here to position all other blocks, is now equal to this current block. And that is that. We are good to go. Here we will need to call one more line of code, but that is going to be later on. And now inside of the start function, we're simply going to say for int I, which is equal to 0, as long as I is less than the max blocks. We're going to say I++, and simply here we are going to say actually not 0, but 1. And here we're going to say instantiate or invoke. Actually invoke, and I'm gonna invoke the create new block, and I'm gonna invoke it in the time manner, which is gonna be I multiplied, where is multiply here, by let's say 0.1f. This is gonna call the function, so it's gonna call the function this create new block, and I'm gonna multiply it actually by 0.05 because 1 is, well, it will take a little bit longer time. So if I go back here into Unity, and let me just go here into the game view. If I hit the play button, notice, do you see how the blocks have spawned? Again, if I play the game, notice how the blocks have spawned. And every time they are spawning with a different way. So again, if I go here, spawning with a different way, as you can see. That all depends on this right here. So it depends on the random chance. So 50% chance it will be spawned ahead, 20% chance to the right, 10% chance to the left. And this is what we are doing. And we can increase this. So if I go here into the block manager and I say 15, and if I hit the play button, we will spawn more of these blocks. And now our cat will need to jump on these blocks to move forward. When the cat leaves a block, we will spawn more blocks, so do not worry about that. I will put this number back at 10. But the point here is, and I've explained it, we are using the random value here and testing it. So if it's greater or less than 50, then we will spawn a block in front of the previous block. And we're using last block and his position. So position Z, and we're saying +1. Because here at the end, when we create a new block, we will set his position to be equal to the position. So this variable that we used here. And I've explained this from the beginning and we saw that. So again, if I hit the play button, notice again, the blocks are spawning. Every time they're going to spawn a different way. Notice every time. And notice sometimes we spawn a stone block. Sometimes we don't spawn the stone block because there is only 1% chance, and I'm using this here, to make sure of that, to spawn a stone block. Just quickly, here, if the random is less than 50, then what we will do is we will spawn the block in front of the previous block. So we are saying here last block, which is the previous block, and his transform position or transform local position Z. I've explained why local position, we saw that. We are saying +1 to position it in front of it. Then we will test if we have actually positioned that game object in front of it. So if we have that game object, and also if the next, so 2 places ahead of it, so from the previous block. So using position, which is this one right here, we added 1 to it. And now we are adding 1 more, which means that we are testing 2 places from the previous position. If the second place is free, then we already spawned in the previous place. We're doing the same thing here except to the right. So here we are saying transform local position X +1 because that's to the right. And we're testing these same things just to the right. So if the second space to the right is free, we are good to go. We can break out of the loop. We created a new block. Same thing we're doing for the left side. Again, I'm just gonna go here and demonstrate that to you. And voila, we are good to go and start adding our cat in our game. So, Fahir here from AwesomeTuts.com, and catch you guys in the next video. Go and download the free project, which is this one that I'm currently building here that you're watching. You can download it along with all of the assets that I'm using here. Link is in the description below. Enjoy with them and see you in the next video.